Alright, so the next moon, Europa. Ice-covered Europa. There's not many craters on this moon either, because as soon as there is, it gets filled in with water ice. So they think there's a possible liquid ocean underneath this layer of ice. The ice is a few kilometers thick, and they believe the ocean is 100 kilometers deep. So if you're looking at Europa, basically it's like looking at pictures of the Arctic Ocean. Right? You've got the ice layer and then the water underneath. Galileo Space Telescope found that the cracks were filled with ice. So if something cracks or, crater or whatever, it's going to fill in with an ice. It's an ice moon. Here's a close-up picture, and you can see the ice kind of filling in different cracks. So they actually called this icy lava, or ice lava. So it's like a volcanic lava, except it's ice. So if you can imagine Hawaii, right, and all those beautiful pictures of the lava flowing on the lands of Hawaii, and instead of hot red, think cold ice. It's literally ice flowing. Alright, so they think Europe actually has some of the same tidal heating as Io. Remember, tidal heating means like the stress ball type. Just not quite as much, so it's not quite as strong. But they think this squishing and pulling actually keeps the ocean underneath the ice liquid. There is a magnetic field here, and we're not entirely sure why. It's not an awesome magnetic field. It changes both in strength and direction. We think it might have something to do with the salty liquid water. So the water underneath the ice is salty. It's like salt water. So again, kind of like the Arctic Ocean. And with it spinning around, the salt is acting like a metal, which is then kind of making the electric field. That's their best explanation that they have right now. And then finally there's this. Where does life start? In the ocean. So if this thing has an ocean 100 kilometers deep, it's possible life started, or life could be, on Europa. Now, on Earth, there's actually things called black smokers that have whole colonies of different types of weird things living down by it. These things do not need the energy of the sun. They actually never see the sun. It's completely pitch black down there. There's no light from the sun, no energy from the sun. The only source of heat and energy they're getting is from the interior. And so they're actually thinking this might be happening on Europa. There might be some sort of black smoker down at the bottom that's getting some of the energy out of the core and the mantle into the ocean, starting life. Obviously not human life, but life. So this is the first place they're looking, and actually the Galileo Space Telescope was extended so that it can answer questions like this.
The search for life beyond Earth begins with understanding life on our home planet. And that story, the story of life on Earth, may have begun in our oceans. And that's because, of course, if we've learned anything about life on Earth, it's that where you find the liquid water, you generally find life. So what if I told you that there is an ocean out there beyond Earth? An ocean in our solar system that has been in existence for billions of years. It's an ocean that is perhaps 10 times as deep as Earth's ocean. It's an ocean that is global and may contain 2 to 3 times the volume of all the liquid water on Earth. It's an ocean that exists beneath the icy shell of Jupiter's moon, Europa. So how do we think we know that Europa's ocean exists? Well, it's a combination of using telescopes on the ground and having spacecraft that have flown by Europa and collected data about the surface, about the interior structure, and about the magnetic field around Europa. And the combination of those data sets leads us to a high degree of confidence that this global liquid water H2O ocean is there today, and it's been there for much of the history of the solar system. We used to think that in order for a world to be habitable, you had to be at just the right distance from the sun or whatever your star was, such that you could have a liquid water ocean on the surface. Now, along with liquid water, life as we know it needs two other keystones. The first is the building blocks for life, the stuff you find in rocks. And the second is some form of energy to help power life. And here's where Europa is a real game changer. It is far, far out from the sun, and yet it's got this liquid water ocean. And the reason that Europa has liquid water is because it's orbiting Jupiter, and the tidal tug and pull causes Europa to flex up and down, and all that tidal energy turns into mechanical energy, which turns into friction and heat that helps maintain this liquid water ocean beneath an icy shell. Along with helping maintain liquid water, we think that tidal energy may also allow that ocean to interact with rocks on Europa's seafloor. And it may even give rise to things like hydrothermal vents, which could help provide not just the building blocks for life, but also the energy for life. The question of whether or not life exists beyond Earth, the question of whether or not biology works beyond our home planet, is one of humanity's oldest and yet unanswered questions. And for the first time in the history of humanity, we have the tools and technology and capability to potentially answer this question. And we know where to go to find it. Jupiter's ocean world, Europa.